Greetings, ladies and gentlemen. My name is Donnie, and today's video will be covering this Mount Olympiad question where we'll be solving for x. Okay, so the first step requires us to understand the Lambert W function, where the Lambert W function here states the following, where we need to have some y at the bottom, where some e is raised to another y, where the y can be represented by anything. It could be x, it could be x squared, it could be anything. And the most important thing is to try and get into this format over here. We need to have a y at the bottom and a y at the top. Next thing is once we acquire this format, then we can apply Lambert W where it simplifies to a singular y. The y could be anything, as I said previously. And we have some w function with some branch number. The branch number will be explained later on in the video. Just know that w, you could think of it as a ln or log function. Just think of it like that. And that's basically what we have to do to try and get into this format over here. And we get this afterwards. So that's our main goal. So the first step requires us to square both sides of the equation, because to get rid of the square root, once we get rid of the square root, we have x to the power of x equal 9. We have to apply ln on both sides of the equation. Then we're going to drop this x to the bottom over here. Then we acquire this. Now we have to apply a little trick to generate an e. So the trick is over here. We can represent x, which is the equivalent statement, to e ln x. Basically, this e and this ln will allow us to solve for this equation because we need an e. As you see over here, the function over here requires an e. So we need to get an e. So we have to apply this over here. So we acquire this. And now it looks like in this format where we have some y with an e raised to y. And over here we have the exact same thing where our y is ln x. So basically we can apply Lambert's w function. So we apply Lambert's w function, it simplifies to 1y, which our scenario is ln x, and we get w ln 9. We raise e on both sides of the equation, the ln disappears, and we acquire this. And now let's move on to the graph. So over here at the graph, we know that this ln 9 is equal to x equal 2.1972. Okay, the next step is understanding the branch numbers. So the branch w of 0 is this orange line. Okay, branch w negative 1 is this green line. This line over here goes all the way to the bottom, curves down, and rx is this pink line over here. Okay, and this is the x asymptote. This blue line over here. Now we have a couple of cases over here. So case 1, is our x greater than 0? In our scenario, well, our x is 2.1972, which is greater than 0. So basically case 1 is what we have, but we're going to go through the other cases. And note the solution is in branch w of 0. As you can see over here, this orange line is w of 0, and that's our solution right over here. Case 2 is if the x is between negative 1 divided by e, which is basically the asymptote I said, and in between of 0. So if our x is between those two values, we're going to have two real solutions, right? In our scenario, no, we don't have two real solutions. We have only case 1. And case 3, if case 1 or case 2 are not satisfied, we're going to have no real solutions. So in our scenario, we have a solution in branch w of 0, as you see in the graph over here. This pink line intersects w of 0. So now we put this number in, which is 0.89648 inside of here. And we acquire an answer of 2.4509. And that's our answer to this question. For practice, solve for this question, x to the power x equal to 6, and post your answers in the comment section of this video. And that's it for this video. So please leave a like and subscribe, and I hope you guys have a wonderful, great day.